Hi everybody. Thanks for joining this talk. Thank you, Edo, for the nice introduction. Before we begin, let me introduce again myself very briefly. I will be very short. My name is Paolo Mainardi. I'm the co-founder and CTO of Spark Fabric. We are an Italian company based in Milan. Well, we have just an office in Milan, but we are a fully remote company now. We do a lot of PHP custom development, mainly with Drupal. Can you hear me well? Okay. Mainly with Drupal, and we do also a lot of cloud-native infrastructures with Kubernetes. I am also part of the Linux Foundation Europe in the advisory board, which is a newborn foundation, the European branch of the Linux Foundation, with the mission, of course, to accelerate the growth of open source in Europe. Feel free to reach me out if you want to know more about the Linux Foundation Europe and how to be involved. You can also find me on my personal blog, paolomainardi.com, where I randomly post things I find interesting, where you can actually download the current slides using that QR code. If you want to take a picture, you all want to follow along during the talk. All right. Let's get started. In this session, we are going to see what is the software supply chain and why it's so important to know today. Then we will see the current state of the PHP ecosystem, the threats and the mitigation we can implement with things like digital signatures, software bill of materials, and finally, how to improve the knowledge about our project dependencies and the strategies to know them more and to choose them more safely. To understand what is the software supply chain, I want to start with a very generic definition, which says that a supply chain is a network of individuals and companies who are involved in collaborating for creating product and delivering it to the consumers. It's super generic, but we can use it to describe any kind of product, including all type of software products. However, open source, you know better than me, that has some specific characteristics and threats that make it very different to all the other industries and products. This diagram comes from the Salsa framework, which is an open source project created by the OpenSSF Foundation, which is a branch of the Linux Foundation. This project is not a software framework per se. Instead, there's a checklist of best practices that we can gradually adopt to improve the security of our artifacts. As we can see, the threats are grouped into three main categories: build, source, and dependencies. The attackers usually tend to exploit dependencies as the main attack vector, which remain the weakest link in our supply chain. It is estimated that today a modern project contains an average number of 500 dependencies, and that over 90% of our code is not actually written by us. Now we can imagine how much we rely on external, unknown actors, and how large the attack surface is just on the side of the dependencies. But attacks, as shown in this map, can take place at any link of the software supply chain, and these kind of attacks are increasingly public and disruptive, like SolarWinds, Codecov, Log4Shell, and the very recent XZ attack that we are going to see later. But before jumping into threats, let's try to imagine the Salsa diagram in action when building a modern PHP application. We, of course, start very simple by installing our frameworks such as Symfony, Laravel, or Drupal. Then usually we need to install other PHP Composer libraries. And depending on how we are building our application, we could need a variable amount of JavaScript dependencies to build our front-end stack or other dependent services. And in addition to that, we may also require other ecosystem more than PHP, such as Python for implementing AI or such. On top of that, we have our operating system, which is strictly bound to our application. We need system libraries for compiling additional PHP extension. This is quite common. We may need a specific kernel. Maybe we are doing things like eBPF or other security stuff. This is quite common in cloud-native environment as well. or having custom binaries such as the tools for converting images and videos, etc. We then usually have a CI/CD system with many jobs to do linting, to do QA, to run tests, to collect metrics, and so on and so forth. Pipelines can even use external services as well, like CodeCov, Coveralls, CodeClimate, etc., which means having external access to our code base, and not just the code base, maybe the configuration variables, our secrets. And when our application is ready, we have to ship it on the cloud. This is quite common, where we have several options like AWS, GCP, Azure, Platform SH, Person, you name it. And when using cloud platforms, we have the flexibility to choose from a wide range of services to deploy our application. And the services may include Kubernetes, object storages, file system, MySQL, Postgres, Redis, Lambda function, and so on and so forth. And lastly, we have our local or cloud development environment, which is another very weird today agglomerate of external dependencies, such as the VS Code extensions, JetBrains plugins, VI modules or bundles, or whatever we use to add more features to our dev environment. It simply means basically adding several other external dependencies in our ecosystem. It's also very common to have access from our dev environment to the cloud, maybe to debug, to see the logs, to check the metrics and such, and this can be quite risky when exploited. As we have seen in the salsa diagram, no point in this chain is free of threats, and attackers will try to use all of them as attack vector, especially when the map of services is so complex and interconnected like this. What we see here is maybe the biggest case in the history of cybersecurity attacks related to supply chain. This case happened in 2020 during the pandemic to this company called SolarWinds. They are a big IT security company, and one of their flagship products called Orion, a software to perform network monitoring at large scale for data center, basically, was compromised by a malware that ran undetected for months and was shipped to all SolarWinds customers as a regular security update. It was later discovered that the compromise was in the SolarWinds build systems, where a backdoor was designed to inject malicious code just during the compilation phase of Orion and then hide itself. It is exactly the point C described in the Salsa framework you see on the slide. The issue was that the biggest tech giants like Microsoft, Intel, Cisco, and others were affected. But even the most important national security agencies like the Pentagon, the Homeland Security, and other important public entities and worldwide national states. This case was so big and concerning that the US Congress invited SolarWinds and Microsoft to testify on the case to understand why companies that are supposed to protect us from this kind of cyber attacks were instead themselves victim of a long-running global or large-scale attack like this. Fast forward to April 2024 for another important and well-organized and quite scary supply chain attack. It's quite recent. Defined as the best executed supply chain attack we have seen described in the open. And it was discovered totally by accident. Let's see how. The story begins on March 29th, when Anders Freund, a Postgres developer working for Microsoft, posted this message on his Mastodon account. While he was doing some micro-benchmarking operations and needed to keep his system load very low, he saw that some SSHD processes were consuming many more CPU cycles than usual. So he got very suspicious and profiled them. Just some minutes later, Anders sent this message to the OSS security mailing list announcing his discovery. It was incredible. Basically, what he found is that someone planted a highly sophisticated backdoor in the XZ library with the intent of compromising OpenSSH with a backdoor. You can scan that QR code to access this message and to read a very interesting, detailed explanation of what this backdoor does and how. But let's take a step back and see what is XZ and how SSH has been impacted by this. XZutils are open source projects that implement LZMA compression algorithms. They are widely used in the Linux ecosystem. Even the Linux kernel is compressed with this library. And OpenSSH does not require XZ, but some Linux distributions, the major ones, patch it to support system denotifications. And the result now is that OpenSSH depends on liblzma2 as an effect of a transitive dependency. So it was vulnerable. This is a textbook example of software supply chain risks related to dependencies, transitive dependencies in this case. The scariest side of this attack is that it required over 3 years of work to complete. In 2021, a new user named Giatan joined GitHub and made his first commit to an open source project. Some months later, he became a co-maintainer of the XZ project, and thanks to his apparently legit work, and even thanks a pressure campaign started by some new users who joined the development mailing list just to accuse and blame the project maintainer Lasse Collin, the historic maintainer, to not update the project very often. This is quite common in the open source ecosystem, you know. In the next 2 years, a series of new patches got merged in XZ, which now in retrospect, they just look like as groundwork for the future vector, but they look like legit at the time. When everything was considered safe and well hidden, Giatan dropped 2 new releases with a vector inside. In the following weeks, using the same social engineering techniques, Giatan and his group pushed developers of Ubuntu, Red Hat, and Debian to merge the new XZ release, and eventually they succeeded, and they were merged in the development branches of these distros. And just for sheer luck, this nightmare story ends here. Andres unveils the backdoor, and XZ gets reverted from the Linux distros. And just only thanks to its nature and the fact that open source means open access to any code base, that Andres Freund accidentally discovered the backdoor just a few days before it was widely deployed with extremely disastrous consequences. The incredible part is that he found it just because his machine was suffering a very little slowness. But the other side of the coin is that open source can be unsustainable for maintainers, who sometimes are required to work under very stressful conditions. They are alone, even when they are working for unpaid hobby projects. This is exactly what happened here, where the maintainer who was suffering from burnout, as you can see in this message, decided to give Giatan a bigger role in the project, as he looked like someone trustworthy, a new contributor on the project. This case is a big security wake-up call for everyone involved in open source. Since 2019, attacks like this have increased by more than 700% per year. The first reason is a great global demand for open source, which is good, because we like open source. The other reason is that modern project requires thousands of dependencies to work, with nothing more, just little knowledge of them. And the other reason is the improvement or inventions of new attacks, such as typo squatting, dependency confusion, injection of malicious code like XZ, and recently even protestware-like attacks. Of course, these cyber attacks also have a big global economic impact. Losses have already been estimated to 46 billion, are expected to exceed 80 billion by 2026. And all these reasons together led government to work on new cybersecurity laws. US government promulgated the National Cybersecurity Strategy 1 year ago in March 2023, which is a long-term strategy to improve the security of organization, and explicitly talking about, for the first time in the history of computer science, about making software vendors liable for insecure software. Even the European Commission worked on a law that is called Cyber Resiliency Act, the CRA, and the purpose of this law is to regulate all the products that incorporate digital elements, which means basically any product that can run software. It is the equivalent of the CE mark that we see in electronic devices since years, but specifically designed for software. If you are interested in the subject, it's quite broad, and you want to know more, you can just follow the link you see on the slide or scan the QR code, and you will find all the Linux Foundation Europe initiatives about the CRA. Well, let's see now the state of the PHP ecosystem and how much is affected by all these issues we have seen so far. Composer is the standard de facto of package management in PHP. It was invented in 2012 by this Aderman, Jordi Bojano, and other contributors. As we can see from the graphs, Composer quickly became a big success with a broad adoption very quickly. And today it holds more than 300K packages, over 3.5 million revisions, and more than 2 billion packages are downloaded monthly. Composer already does a great job on protecting us from the most common cyber security supply chain attacks. When we install a new package, we are required to use a namespace, such as Drupal, followed by the library name and optionally a version. Only the first two parts are mandatory. As the only vendor namespace packages are allowed, the risks behind typo squatting attacks are drastically reduced. Typo squatting is when a package is created with a similar name, trying to take advantage to exploit some misspelling or typos in the name, like Google with 3O, for example. Composer only hosts metadata of the libraries, while the code is always hosted outside. This is another nice security advantage because it reduces the risks of code tampering if packages.org is exploited. And a case like this, like XZ here, will not be really possible. And finally, Composer allows to have multiple repositories in addition to the default public one, which is the packages.org. And when present, these repositories are considered canonical by default. What does it mean? This means that if a package name is found on a user-defined repository, only the versions from that repositories are loaded. This is a very good protection for an attack known as dependency confusion, which affects many other package managers like PyPy or NPM. Nevertheless, despite all the Composer built-in security features already in place, only in the last 3 years, many dangerous supply chain attacks have been conducted against Composer. The latest one happened in May 2023, where someone gained access to an inactive user account, becoming maintainer for at least 14 popular packages. So what? Are we doomed? Is there anything that we can do to mitigate, to anticipate this kind of attack? Yeah, I think that the starting point should be working to ensure trust and the integrity of our dependencies. This is the starting point. So the question is, what is the trusting model between us and the digital artifacts? How we can be sure that what are we running is really coming from someone who's claiming that is the author, or that inside the packages there is alleged code? Well, it is essentially the same question that Ken Thompson posed in 1984 in his famous paper, Reflections on Trusting Trust. And the answer was that we cannot really trust the code we don't totally write ourselves. Instead, we should put more trust in the people who wrote it. Considering the big amount of used dependencies today, it's pretty impossible to know the thousands of people involved. Maybe when Ken Thompson wrote this, it was possible. Today, doing that manually is not a human being task. So, to enforce the integrity and trust, we need to know at least for the artifacts who build it, when and how. And we can use things like digital signatures and provenance attestations. And also we need to know the list of things who made the artifact, which is basically the list of ingredients of food. Using digital signatures with key pairs, we can solve the first set of problems because they ensure integrity, authenticity, and non-repudiation, which are the key elements in building trust between known and unknown actors. But the problem is that managing keys is very hard and boring. We have to deal with distributing the keys. We have to keep the private keys in a very secure place. And if, or better, when they are compromised, we have to revoke the old keys, inform our network of users, and start this process again and again. This is why digital signatures are not yet widely used by end users, even though they have existed for decades. But there is a new project called Sigstore from the OpenSSF Foundation, which aims to fix the issues related to managing the keys. The goal is to become what Let's Encrypt has been for TLS certificates. One of the ways Sigstore allows to sign artifacts with keys, it is implementing a keyless signing approach. It works by using a public identity like GitHub, Google, or whatever OpenID Connect provider supported to generate a short-lived certificate and use it to sign on your behalf. So we can get rid totally of managing keys. Another interesting feature is that signatures can also be stored in the OCI registries alongside images, removing even the distribution issues. The biggest issue here is that not yet usable with Composer, as Composer just hosts metadata, as we saw before, but there are some initiatives ongoing. The most advanced one is the Drupal2 initiative that you can find linked on the slide. The other key element in the software supply chain are the software bill of materials. They represent the list of ingredients of our artifacts. We can use it for things like vulnerability scanning, license policy, find abandoned dependencies, and so on and so forth. There are, of course, various tools available that can help us with generating SBOMs. The most advanced one are Syft, Trivy, and Docker that now has a built-in tool to generate SBOM. But in the case we want to generate the software bill of materials without depending on external tools, just using PHP for our PHP code base, we can simply use the CycloneDX PHP Composer library. Well, we have seen the importance of digital signatures, software bill of materials, to help us to improve the trust, the integrity, and the transparency of our artifacts. But how can we wisely and safely choose our next project dependencies while navigating the vast oceans of the open source ecosystem? Yeah, vulnerability management is still one of the major issues. The issue is caused by the fragmentation of the ecosystem and no actual easy ways to automate the tracking the issuing process. So OSV was created to address all these challenges, basically. OSV is a project born in Google and now is part of the OpenSSF Foundation, supported by. And it consists of two main parts: a new data format, the OSV schema, which is designed to contain information like versions, package names, and ecosystem, with the intent to make it easy to consume for human being, for system, and more open source specific. This is the big leap forward. Another key element is the OSV database and its free API, which is a database of known vulnerabilities populated from various sources, with the goal to provide precise and actionable information that can be directly integrated in development and security workflows. It is very well adopted. It supports a big ecosystem right now, such as Go, Rust, Python, Node.js, PHP, of course, and various Linux distros. But even Composer has its own mechanism to scan and report vulnerabilities that was introduced in Composer 2.4. It's quite easy to use. Once executed, it lists the vulnerabilities found in the Composer log file. It uses the packages.org security API that you find linked on the slide that is populated from various sources. And it can be easily integrated into CI as it returns a non-zero when a vulnerability is found. Another important aspect of picking up new dependencies is how to understand the overall quality of a project, not just in terms of code quality, but even about security practices, contributions, active maintenance, continuous integration, and in general, all the non-functional aspects that are part of the quality equation. Well, doing all those checks manually for each dependency we are going to choose, it's almost impossible for a human being. This is where the OpenSSF scorecard project comes in help. It consists of a set of automated checks that anyone can run on any open source project by using the CLI or by integrating it in a CI/CD pipeline. And each check returns a score out to 10 and a risk level, which are then used to calculate an aggregated score to represent the global security project score. And alongside the score, this is quite cool, the tool also provides remediation prompts to fix the discovered issues. Well, what if we could have something that automatically could manage dependencies for us? Maybe even opening and merging pull requests for critical security vulnerabilities. It is something magic? No. Because both Renovate and Dependabot can do that, and they can do much more than this. Renovate is an open source project that you can use everywhere, while Dependabot is a GitHub native project. You can just use it there. But basically, they share a similar set of features with the same goal of automating the entire life cycle of dependency management, basically. I suggest you to try them, as they are very straightforward to integrate, to configure, from simply to more advanced scenarios. So, just some takeaways. We saw a lot of stuff. Software supply chain risks are a real threat, and they will increase a lot in the future, as open source is now the standard factor for developing new solutions. We can improve the integrity and the knowledge of our dependencies using modern cloud-native tools like Sigstore, Syft, Gripe to sign, to generate the software bill of materials and check for vulnerabilities. And thanks to projects like OSV, Scorecard, Deps.dev, we can choose our project dependencies way more safely and more informed than before. And finally, we can automate project dependencies lifecycle using Renovate or Dependabot, so we can get rid of the most boring tasks like upgrading dependencies, maybe minor versions, and also to be quicker to integrate security fixes as they are publicly released. As a bonus, I recorded a demo because I thought that this talk was 45 minutes, but it was just 30. You can find, reach it scanning the QR code or following the link, where I show you all the tools in action on how to use Sigstore to sign a PHP container, how to generate the software bill of materials, and how to scan for the vulnerabilities and the strategies to reduce the attack surface when using containers by changing the source image with something called like distro-less. So, I think that I'm done. Thank you very much for your attention.
Thank you. Thank you. Thank you, Paolo. If we have some questions there, otherwise I have one from home. Composer dependency can download, unzip, make executable, move, etc. a file, though many of them do that for absolutely legit reason. Yeah. Pest plugin stressless, a useless plugin for pest. How can I monitor, keep track of those hidden dependencies in my SBOM?
Yeah,
you want to read
it?
The last one.
Okay. The question is that a composer dependency can download something that is not tracked by the composer.json file. I don't know. I don't think that there is now something that can check that. Maybe something like Scorecard can have a check like that. We can add it, for example.
I think they have like a list of best practices that you can check on your repo.
They can scan the package, and if you try to download something that is not tracked by the composer.json file, I don't know if they...
Yes, for example, you can forbid to add the binary files to the repo or scripts like install scripts or something like that. Okay, thank you. Other questions over there?
Hey, so the XZ vulnerability managed to land into some distributions because it was eager merging of upgrades happening all the time. So you can obviously catch vulnerabilities when you know there is one, but this is like very fresh off the press. Is there a strategy, maybe an idea of how to approach these problems as a community? Like, don't upgrade this because we just figured out it's broken, or vote on something?
This is a very good question. I don't think that can be used as a tool to fix that, because they are basically social engineering techniques. They force the maintainer to merge new patches and force the distributions to upgrade very quickly.
Yeah, and more like Renovative and Dependabot are great, but they're also part of the problem.
They are part of the problem, yes. Yeah, one of the problem is that we have to, I think that we have to to set a milestone for the projects that when they are done, and it's not an economical money problem for maintainers. It's not the money problem. It's that they are alone. They are forced. They are. Someone can use social engineering techniques to inject malicious code. So it's an ecosystem problem. It's not a technical problem, I guess. I don't know if we can fix it with a tool, because it was quite impossible to discover with something automated that XZ contained a backdoor, just because Andres unpackaged everything, discovered that. So the issue is in the ecosystem, at the ecosystem level instead of the technology level, I guess.
Other questions? One. We can take one last.
Thank you. I have an unpopular question, but from what we have seen right now, the most recent vulnerability, and this is a really critical one, is the closed source the answer when we have a critical environment?
I don't think so, because if the ecosystem was closed, no one were able to discover this backdoor, basically. So we have to balance the good and the bad. The fact that with open source we had this backdoor, but the other side of the coin, that we found the backdoor just some minutes later, just some minutes before it was widely deployed. So I don't think that closed source is a solution here. Maybe there are many closed source software with backdoor inside that we'll never find. So open source is always better.
Thank you,
Thank you.
Paolo. A big round of applause.